So if you could take out your graphs of polynomial functions, we're going to just take a look at number 15, 17, and 19. Okay, so let's start off by looking at number 15. Now, number 15 appears to be a cubic function, right? It appears to have 1, 2, 3 directions. So f of x or y equals x to the third power. Actually, f of x, because that's what they give us right here. All right, so letter A just wants to know what are the x-intercepts. So they're just asking us where the graph intercepts the x-axis. So these three spots that I just pointed to. Now, if they had asked for the zeros instead of the x-intercepts, you would just write the x values. X equals -3, x equals -1, and x equals 2. But when they ask for the x-intercepts, they want you to write these as coordinates. So if you just want to put that in your notes. Okay, they don't want them as just the x value. They want you to write them as coordinates. Okay, so then we would have, let's see, -3, 0 would be the first coordinate. -1, 0 would be the next coordinate. And +2, 0 would be the third coordinate of our x-intercepts. Letter B says to use these x-intercepts to write an equation for f of x. So, all right, well, first of all, let's write f of x equals. Okay, that's just really another way of saying y equals. So f of x equals. All right, so if you guys recall, if we have, let's say, an x-intercept, or let's just say if we have a 0 at x equals -3, then what that means is our function is going to have a factor of x plus 3. If we have a 0 at x equals -1, then our function is going to have a factor of x plus 1. And if we have a 0 of x equals +2, then our function is going to have a factor of x minus 2. Now, if you notice, I left a little space right here, and that's because sometimes your function can have some constant value, right? Like we could have a 2 in front of this function. We could have a -4 in front of this function. We could have a number in front of this function. So what we're going to do for right now is we're going to put a C to represent the constant because we could have some number in front of that function. Now, we can tell right off the bat, if we look at this, if it's a cubic and it's going down first, then what's going to happen is this is going to be a negative function, right? We're going to have a negative leading coefficient. So we know right off the bat we have to have something there. All right, and then you'll see later in the problem it's going to ask us to determine what that is. All right, but let's go to letter C. Letter C says to estimate the relative extrema for the function graphed above. Okay, now when they are asking for the relative extrema, all they're looking for you to do is to determine the relative minimum and the relative maximum. And they're just asking for an estimate. So just one thing I want to point out. If the question says find the relative maximum value, okay, if you see this word value, so find the relative maximum value, then the only thing they're looking for is the y value. But since this question doesn't ask for the value, it just says what is the relative maximum and what is the relative minimum, we're going to write these as coordinates. All right, well, let's start with the relative maximum. I mean, this right here, to me, it looks like we're at the coordinate 1, 8. So I'm going to estimate the relative maximum to be 1, 8. And the relative minimum is right over here. So I would estimate that to be at -2, -4. Okay, so letter D says to use the relative maximum to find the leading coefficient for this function. So if you guys recall, in letter B, we put a C here to represent some constant term that we could have in front of our function. This could be our leading coefficient. So it says to use this point right here, the relative maximum, to help us find the leading coefficient. All right, well, if we were to use this point, this would be our x value, and this would be our y value, right? It always goes x, comma, y. So can't we take this x value of 1 and replace it for all the x's in our function? And can't we take this y value of 8 and replace it for the y value, right? Remember, f of x is another way of saying y. So can't we replace this with our y value and these x's with the x value and use that to help us solve for this c right here? All right, so let's do it. So again, we're going to replace f of x. We're going to replace this y with the y value. So we'll have 8 equals. Now this c is what we're solving for, so I'm going to leave that as a c. And then I'm going to replace each of these x's, here, here, and here, with a 1. So instead of x plus 3, we'll have 1 plus 3. Instead of x plus 1, we'll have 1 plus 1. And instead of x minus 2, we'll have 1 minus 2. All right, so let's just solve for c. So let me bring down the 8. I'm going to bring down the c. And then, let's see, 1 plus 3 is 4. I might as well just write these. So we have a 4. 1 plus 1 is 2. And 1 minus 2 is negative 1. So bring down the 8, bring down the equals, bring down the c. If we multiply 4 times 2 times negative 1, that gives us negative 8. So to finish solving for c, let's just divide both sides by negative 8. And that leaves us with c equals, well, 8 divided by negative 8 is negative 1. So this is the answer. So just off a side note, our function right here, we could now rewrite by replacing a negative 1 here. So I'm just going to kind of do that off to the side. So our function is, I'm just going to put it off here, is f of x equals negative 1 times x plus 3 times x plus 1 times x minus 2. And if we wanted to write that in standard form, we'd have to multiply all that out. All right, so let's see what letter C is asking. I'm sorry, what letter E is asking us to do. Let me just move this up a little so we could see. All right, it says, using your equation from part B and the leading coefficient from part D, so that's what we did right here. We kind of put it together as an equation. Determine if your estimation of the relative minimum, I'm just going to skip this part, is accurate. All right, well, we estimated the relative minimum to be negative 2, negative 4. So why don't we take this negative 2 and replace it for all of our x's in our function? And why don't we take this negative 4 and replace it for the y in our function and see if the left-hand side of the equation equals the right-hand side of the equation. Okay, so again, we're using the relative min. So f of x, which really means y equals, I'm going to replace with our y value of negative 4. Okay, then I'm going to bring down my equals. I'm going to bring down my negative 1. And then here you could see we have in parentheses x plus 3. Well, I'm going to replace this x with the x value of our relative min. So we could rewrite that as negative 2 plus 3. Okay, and then instead of having x plus 1, we're again going to replace that x with a negative 2. So we'll have negative 2 plus 1. And we're also going to replace this x with a negative 2. So we'll have negative 2 minus 2. All right, so let's bring down our negative 4, bring down the equal sign. I'm just going to, for right now, bring down the negative 1 and determine what we have in each of these parentheses. So negative 2 plus 3 is 1. Negative 2 plus 1 is negative 1. And negative 2 minus 2 is negative 4. All right, so let's bring down our negative 4 equals, and all right, let's multiply this up. So negative 1 times 1 is negative 1. Negative 1 times negative 1 is positive 1. And positive 1 times negative 4 is negative 4. So this actually checks out exactly. So what we could say is, yes, my estimation of the relative minimum is accurate. Let's see if we could fit this. Pretty much. Okay, there we go. Okay, so if you could flip to number 17. It says, Mrs. Fasano has a rectangular piece of paper. She would like to construct a lidless rectangular box by cutting squares out of the 4 corners and folding up the sides. The figure below shows the graph of a cubic polynomial function used to model the volume of the rectangular box as a function of the height. Okay, so they're telling us that this cubic is used to model the volume as a function of height. So instead of writing f of x for this one, we're going to do volume in terms of height. So we'll call that v of h. All right, I probably should have picked something other than red because the red is kind of clashing with the purple a little, but that's okay. All right, so now let's read part A. It says, estimate the x-intercepts of the function used to model this data. So again, when they ask you for the intercepts, okay, what they're looking for is they want you to write them as coordinates. All right, so it looks like we have 3 of them. I think this would be at 0, 0. That looks like it's about at 2.50. And this one looks like it's at 4, 0. So we'll just list those out. We have, okay, we have 0, 0. We have 2.50. And we have 4, 0. Okay, we'll just box that off. So letter B, use the h-intercepts to write a formula for the function of the volume of the box V in terms of h. So again, we have volume in terms of h. Now, we know that if we have, well, I'm going to start with this one. If we have an an h-intercept, if we have a root of 0, then your factor, I mean, you could write as h minus 0 or h plus 0, but if you combine h minus 0 or h plus 0, that really just gives you h. So we know one of our factors is going to be h. All right, now, if we have a 0 at 2.5, we know that our factor is going to be x minus 2.5, or in this case, since we're using an h, we're going to write h minus 2.5. And if we have a root or a 0 at 4, positive 4, then our factor is going to be h minus 4. And again, I left a little space in the beginning of the right-hand side of this equation because we want to put a c here to represent some constant that we can have in front of our function. Letter C says to use the relative maximum to determine the leading coefficient and explain your reasoning. All right, so it looks like the relative maximum is right here. It's kind of hard to see on your paper because the lines of the grid aren't completely accurate, but I could actually see it a little better here. We could see that that maximum point is at positive 1, positive 18. So 118 would be the maximum point. So what we want to do is we want to use that point to help us determine the leading coefficient. So here's our leading coefficient. And if we want to use this point, we know the x value, or the h value in this case, is 1. So I'm going to replace all these h's with 1s. And we know our y value, or the v of h value in this case, is 18. So we're going to replace that with an 18. All right, so let's write it out. We have 18 equals, we're solving for our constant. We said we're going to replace all the h's with 1s. So instead of h minus 2.5, we'll have 1 minus 2.5. And instead of h minus 4, we'll have 1 minus 4. And let's just use this, and let's solve for c. All right, so I'm going to bring down the 18. We have c times 1. 1 minus 2.5 would be negative 1.5. And then 1 minus 4 would be negative 3. All right, so we'll bring down the 18. We'll bring down the equals c. And if we multiply 1 times negative 1.5 times negative 3, that'll give us positive 4.5. Okay, and let's just divide by 4.5 to get c by itself. And when we do, we wind up with c equals 4. So what that means is, I'm just going to do it in a different color. If we wanted to write an equation for our function up here, we could now replace this c with a 4. So I'm going to just go ahead and do that. So our function is now v of h, the volume in terms of height, is equal to 4h times h minus 2.5 times h minus 4. All right, and finally in part D, it says to use your function to estimate the volume when the height is 2 inches. So what I did was I just rewrote our function right here. And if we want to estimate the volume when the height is 2, let's determine what v of 2 is. Let's replace every h, let's replace all those heights with 2's. All right, so we could write this out as v of 2 equals, and if we replaced this h with a 2, we're going to replace all of our h's with a 2. So we could write 4 times 2, and then in this parenthesis we'll have 2 minus 2.5, and in this parenthesis we'll have 2 minus 4. Okay, so you don't have to keep rewriting v of 2. You could just bring down an equal sign, and that implies that whatever you write here is equal to the last thing you wrote on the left. All right, so let's just do 4 times 2 is 8. 2 minus 2.5 would be negative 0.5. And 2 minus 4 would be negative 2. Okay, so if we multiply these together, negative 0.5 times negative 2 would be positive 1. And positive 1 times 8 is just 8. So the volume when the height is 2 would be 8 cubic inches. Remember, when you're talking about volume, it has 3 dimensions. It's 3-dimensional, right? A length, a width, and a height. So when it's 3-dimensional, you want to label it with a cube. All right, so there we go. All right, and the last one we're going to take a look at is number 19. So number 19 gives us a graph of f of x, and the first thing they want to know, what is the degree? So by looking at it, I mean, I would think, let's see, we have 1, 2, 3, 4 directions. So I would assume this to be a 4th degree polynomial. Okay, letter B says, what are the zeros with multiplicity? Now this time they're asking for the zeros, so we don't want to write them as coordinates. All right, so if we look here, we have a 0 at negative 5, a 0 at negative 1, and a 0 at positive 1. So let's just write this out. X equals negative 5, x equals negative 1, and x equals positive 1. Now they asked for multiplicity. And if you remember, I mean, if it just crosses through the x-axis like it does over here and over here, it's just going to have multiplicity of 1. But when something is tangent to the x-axis, it hits it and bounces off like that, then what we could say is it's going to have multiplicity of 2. All right, so you guys can just kind of write this off to the side here. You could pause it a minute if you want to write that. All right, now letter C asks for the x-intercepts of g of x. So what they want us to do is now they want us to write them as coordinates. So, okay, so if we have a 0 at x equals negative 5, if we were to write that as a coordinate, it would be negative 5, 0. If we have a 0 at x equals negative 1, then the x-intercept would be negative 1, 0. And if we have a 0 at x equals positive 1, the x-intercept, when we write it as a coordinate, would be positive 1, 0. Okay, so letter D asks us to use the zeros to write an equation for g of x. All right, so g of x equals. So now at this point, we know we're going to start off using a c to represent some constant that we can have. So if we look at, actually, I'm just going to look above. If we look at the 0 of x equals negative 5, we know if the 0 is at negative 5, the factor would be at x plus 5, right? It has the opposite sign. Now, one thing I want to point out, when it says that we have multiplicity of 2, what that means is we're going to actually have 2 factors of x plus 5. So you could either write x plus 5 and then write another x plus 5, or if we have 2 of them, can't we just put a little square there? All right, if we have a 0 at x equals negative 1, then the factor to go along with that would be x plus 1. And if we have a 0 at x equals positive 1, the factor to go along with that would be x minus 1. Okay, letter E. Letter E just wants to know how many relative minimums does g of x have? So the relative minimum is just the minimum point within a specific area of the graph. So it looks like we have a relative minimum right here and a relative minimum right here. So we could say we have two of them. All right, letter F wants to know how many relative maximums does g of x has. So it looks like we have a relative maximum right here. So there's only one of those. Okay, letter G says the graph passes through the point -2, +27. Use this point to find the leading coefficient for this function. So in letter D, we wrote an equation for our function. So we know g of x represents the y value, and we have a whole bunch of x's right here to represent an x value. So if we want to use this point right here, we could take the 27 and replace it for the g of x. And we can take this -2 and replace it for each of these x's. Okay, so let's just solve and see what we have here. So I'm going to bring down the 27 equals c. All right, so -2 plus 5 is +3, and 3 squared, right? Don't forget about that square there, is 9. -2 plus 1 is -1, and -2 minus 1 is -3. So if we multiply together 9 times -1 times -3, that's going to give us +27. So I'm going to bring down this 27, bring down the c, and again, when we multiply all those three numbers, we get 27. So to finish solving for c, let's just divide both sides by 27. And here, our leading coefficient is 1. Okay, so our function, I'm just going to rewrite our function in letter H because it winds up, we're going to need that anyway. So we have g of x, let's hope I can fit this, equals, well, in place of this c, we have a 1. I mean, if you want to write it, you can. I'll write it, but you don't need it. Times x plus 5 squared times x plus 1 times x minus 1. Okay, so it says to use this equation to evaluate g of -6. So if we want to find g of -6, well, if we replace this x with a -6, we're going to have to replace all these x's with -6. Okay, so you can bring down the 1 if you want, that's up to you, but we'll have -6 plus 5 squared, and then we have a -6 plus 1, and we have a -6 minus 1. All right, so if you want to bring down g of -6, you can. If not, you could just bring down the equal sign. All right, so we're going to be left with 1. -6 plus 5 is -1, and -1 squared is +1. -6 plus 1 is -5, and -6 minus 1 is -7. If we multiply all this out, we'll wind up with a +35. So g of -6 is equal to 35. Now it says, does this seem reasonable based on the graph above? So let me just scroll back up to the graph. Does g of -6 equal 35? All right, so let's scroll up and see. Okay, it's kind of hard for me to be exact with this pointer here, but -6 is right here. So if I follow that up to the graph, it looks like the lines are like right about here. I would say it's like right about there. If you could see where the line is on this. It's kind of hard to see the line on your paper because the photocopy job isn't the best, but I would say it's somewhere right about here. So if I look over to the y-axis here, let's see. If this is 0 and this is 50, it looks like they're going up by 10, so this would be 10, 20, 30, somewhere in the middle. Yeah, it looks like it's about at 35, which is exactly what we got. So what you could say is, yes, this seems reasonable. Now, I do have to say, on your paper, because I have the paper next to me as well, the photocopy job is really bad. It actually, on your paper, you can't really see the lines. And when you follow it up, it almost looks like it's in the 20s, but I could see it better on the picture that I have right here on my iPad that I'm making this video on, and 35 does seem reasonable.